السادة الحضور شكرا جزيلا. شرفتونا. We were charged by the Water Authority of Riyadh to investigate the failure of an electrodialysis desalination plant. An electrodialysis desalination plant failed. How and why, and how we can recover the production of drinking water according to the norms of the World Health Organization or the Saudi standards of 11 of 300 milligrams per liter of total dissolved solids. The visit of site inspection showed failure of performance. First, the salt rejection failed. The plant, the salt rejection failed. The analysis of the raw water and of the product water showed the failure of rejection from 1,700 to just 1,600. In fact, the product water was delivered to the distribution network at above 1,600 milligrams per liter, which is not suitable for drinking, of course, nor for cleaning purposes because of high hardness content, and it could cause corrosion to the network piping. The production rate of the plant was reduced. The production rate of the plant was reduced to 12,000 cubic meters per day instead of 20,000. The percent recovery of desalination was as low as 60%, which represents an exaggerated loss of water and too high rejected disposal rate with evaporation bombs. The plant consumed important amounts of highly expensive raw materials, as for example, nickel chrome electrode of 1 square meter surface area and hundreds of selective membranes, cationic and anionic, for a rather short lifetime. We have detected also cross leakage between the chambers. This is the electrodialysis cells. The nickel chrome electrodes, the potential difference across the nickel chrome electrodes push the ions towards the electrode of opposite direction to concentrate the water in certain compartments and dilute the water in another ones. We have detected also cross leakage between these chambers. The cross leakage between the dilute water chambers and the concentrated chambers, which decreased even more salt rejection. We have also detected radioactive contamination of groundwater from the uranium series and the thorium series. Natural salt. Radium 226 degrade to give radium 223, which is a radioactive gas. This situation, beside the other defects in the plant, imposed us to replace the electrodialysis technology by reverse osmosis. In fact, reverse osmosis technology is qualified by the Environmental Protection Agency of the United States as being highly effective in rejection of radioactivity, besides its high efficiency in rejection of salts. while electrodialysis, even with new electrodes and new membranes, could not reject efficiently radioactivity. As for the relative importance of the two technologies, we find that more than 60% of the desalted water produced in the world is by reverse osmosis, while just 3% of which is produced by electrodialysis. One may ask why, in this case, Saudi Arabia went to do electrodialysis. In fact, the problem is that the desalination industry in Saudi Arabia is very old. So from 50 years or 60 years, the reverse osmosis was not as developed as now be. So the best technology by the time was the electrodialysis. We have investigated the radioactive concentration of groundwater and discussed the efficiency and the advantages of its rejection by reverse osmosis and nanofiltration. Here, one of our results, as an example of our results, this figure shows the desalination performance of reverse osmosis, low energy reverse osmosis, and nanofiltration. The rejection of radium and uranyl cation was computed from activity measurements. Of course, low rejection is observed with monovalent ions, while with polyvalent ions, strong rejection was obtained. And low energy reverse osmosis succeeded to reject radioactivity to less than the maximum contaminant level of drinking water according to the Environmental Protection Agency of the state. Another advantage of reverse osmosis is that the harmless isotopes were strongly rejected, despite the fact that these isotopes were present in trace concentration and presence of much more important concentration of similar ions. In fact, radium and calcium are members of the same group as the periodic table. So the fact is that the trace concentration of radium was rejected at higher percentage than calcium shows that the reverse osmosis do not show interference between the rejection of trace contaminant ions. Here, this is the design projection of reverse osmosis. The system design projection of reverse osmosis unit, which is proposed to replace one electrodialysis unit. Here we observe in the beginning the high salt rejection. The raw water. I've asked the gentleman to find a pointer, but I did not find. So the raw water at 1,800 milligrams per liter if only. كويس كده انا بس the variation water was only 24 milligrams per liter, and this gives an salt rejection above 98%, much higher than the rejection obtained with electrolysis. Another advantage is that another advantage is that the percent percent recovery is higher than 80% as compared to just 60% because it's of electrolysis. And this decreased a lot the consumption of raw materials and decreased the rate of rejected disposal to evaporation ponds. However, one disadvantage here is that the feed pressure, the feed should be at the pressure of 15 bar as compared to just the circulation pressure in case of electrolysis. So the main cost here is to have a high pressure pump for each electroosmosis unit. We notice that calcium and magnesium dehydrates are strongly rejected, which may be later on as an advantage in scaling formation. We notice also that silica is strongly rejected. This system design is correct. There is no design warnings, and it was confirmed by Filmatech data. As for the scaling calculation, at this high percent recovery, several compounds resulted in scale formation, and we have investigated the chemical treatment required to avoid fouling and the scaling of reverse osmosis membranes, which is shown here by, for example, calcium carbonate exceeds 100% injection for the give scale formation. Same thing with calcium sulfate, calcium chloride, iron, but not silicon. We have investigated the chemical treatment required to avoid this scaling formation. Here, by injection of the Genesis LF antiscalant. Genesis is a company supplying chemicals for treatment, and with also adding sulfuric acid to lower the pH value, the scaling of all the items is removed. The process description of our plant now is first the raw water is pumped to the cooling reaction tower from the raw water collection tank to lower the temperature to the desired range of 25 to 30 degrees centigrade. On the other hand, we have a problem here. As we said, that radon 226 is integrated to give radon gas 222, which is a radioactive gas. And being heavier than air, it will fall down. So to protect the plant workers from respiring radioactive gas, we have applied a strong upward flow of air to dilute radon, which will come out at the top of the plant at acceptable concentration. Then the effluent stream of the tower being injected chlorine gas to avoid biofouling or reverse osmosis membranes and to oxidize the excess ferrous ion to the insoluble ferric ion, which will get separated later on by filtration. We also injected a liquid coagulant to optimize the filtration efficiency and lower the self-penetrating sulfuric acid is used to avoid the scaling formation of calcium sulfate, calcium carbonate. Then the rest of my classical sequence of processes in reverse osmosis plants. After multimedia filtration, we have chemical dechlorination by using of hexametal sulfide to remove the excess chlorine to avoid the damage of and polyamide reverse osmosis membrane by oxidation, and scale and dosing. Then fine cartridge filtration. Fine cartridge filtration, so cartridge filter to lower certain units and 0.5 before dumping of the water to up to the desired working pressure to the reverse osmosis scale. For drinking water quality, we have to use calcium hydroxide to rectify pH and the calcium content of water to the correct range of drinking water, and this permeate water is very low salinity, as we said, and be blended with an adequate amount of the raw water, the conditioned raw water. Conditioned, we mean filtered and sanitized. So low salinity of the permeate water and the high rejection of radioactivity enable this blending with raw water to increase the total product rate. After that, we reject the brine stream is rejected to evaporation ponds. Advantages of replacing then of electrolysis to reverse osmosis. We have already mentioned higher salt rejection, which enabled to increase the total product rate upon blending with conditioned raw water. Higher percent recovery. The higher percent recovery of reverse osmosis saves the overconsumption of raw water. It saved 700 cubic meters per unit per day, and decreased much a lot the rejected disposal rate to the evaporation ponds. Removal outside components. As we said, the electrodialysis set function by the electric potential difference between the electrodes. So the different ions move towards the electrode of opposite potential to concentrate in certain chambers of the cell and the dilute gases, but the non-charged component do not remove. For example, electrodialysis cannot remove silica. Electrodialysis does not remove organic compounds, which are neutral, while these components are strongly rejected by reverse osmosis. The required spare parts, of course, of reverse osmosis are much lower in quantity and in cost as those of electrodialysis. When we were working in the plant, the electrodialysis plant has over 120 nickel chrome electrodes for 1 square meter surface area for operation period of 6 months. Another final problem of this replacement is that it helps to get rid of the monopoly of the sole manufacturer in the world of electrodialysis spare parts, who have increased a lot the price of these spare parts. And with reverse osmosis, we profit from competition between several manufacturers of reverse osmosis components. Finally, and I'm sorry for being too long. Finally, according to our investigation, and due to the demand situation of Sudan, the Water Authority of Riyadh accepted to modify one electrodialysis unit to reverse osmosis, low energy reverse osmosis. And luckily, according to the successful realization of the design performance, the whole plant was awarded for modification to low energy reverse osmosis. Thank you very much.